All right, good afternoon. Welcome. Happy Friday. Hope everybody is having a good day. Let's see here. Let's say hi to some folks in the chat. Let me find my chat windows here. Let's put this one up. Good evening, good day. How's it going to C. Grover, as well as Jeff and DJ Devin? Got some Pacman GIF action going here to get us ready. Foreshadowing for anybody who hasn't seen the title right there. Let's see, where is this one? Let me put it like that. I got it really buried down there. There it is, okay. Sunny and 65 in LA, which sounds pretty good to me. It is, it's sunny here. We have actually managed to get some sun for the last couple of days, but nowhere near 65. I'm not sure. I don't think we have made it back above freezing all the way yet, but we're much warmer than we were last week, so I'm feeling pretty good about it. All right, let's do, let's see here. Can find this one. Or, oh, that is not what I meant to do. Let me see here. I've messed up my OBS somehow. One second. We're going to switch this. Okay, here we go. Somehow I got this browser stuck without being able to be seen, but we give it the old flip-flop around and we're good to go. All right. Work on the font issue. It was a font. Last week we were looking at something in DisplayIO, which was, or I should say with display text, which I do think was in the font. We're not, that's not what I'm working on tonight though. Tonight we're on a new thing, which I'll tell you about in just a moment, but let me start off with the kind of top level intro for anybody that might be new. Welcome, first of all, thanks for tuning in. My name is Tim. I go by Foamy Guy on GitHub and Discord. This is the Deep Dive, which is a weekly live stream program. It was started by Scott Shawcroft, the lead developer of CircuitPython, and when Scott's not available to do it, then I will be here streaming if I'm available. And CircuitPython, if you are new and you don't know what that is, you can learn more at circuitpython.org. This is basically a version of Python that can run on tiny computers called microcontrollers. There's a bunch of pictures of them over here. Basically, these little devices will plug into your computer with a USB port, most typically, and then it shows up like a thumb drive, and you can edit the code file that's on that thumb drive and save it. And the computer that's actually inside this little chip on this microcontroller will read and interpret your Python code and execute it for you. It can interact with other peripherals. Oftentimes these microcontrollers come with lots of these little I/O pins along the edges where you can connect up other stuff. And there are all sorts of different shapes and sizes of these devices with all sorts of different capabilities built in. Some have alligator clip little holes there. Some have the pins that let you plug them to a breadboard and built-in battery charging. Some have displays with touchscreens. Some have buttons and knobs and screens and all kinds of different things going on with these microcontrollers. The 469 of them that are listed on this page, though, all can run CircuitPython, which is kind of the primary focus of this stream. Sometimes when Scott's here, it tends to be working in the CircuitPython core, kind of on cutting edge stuff. When I am here, I don't go quite as deep. We raise the level a little bit, and typically I'll be either in library land, or today we'll be working on a project where we're just using CircuitPython code in the project, not working on the infrastructure or the libraries or anything like that. So, but if you do catch it when Scott's here, it tends to be way more, into the core, working on the cutting edge stuff, brand new stuff. So tune in if you are interested in that sort of stuff. Thanks to everybody for watching along. Adafruit, this is their website, adafruit.com. Adafruit is the company that allows CircuitPython to exist by paying the folks who work on it. Scott, who does this stream, is paid by Adafruit full-time. Like I mentioned before, he's the lead developer of CircuitPython. There's a couple other folks who are paid by them full-time to work on CircuitPython, and there are other folks like me who are paid part-time to work on the project. So huge thank you, as always, to Adafruit, and if you want to help support CircuitPython, kind of the easiest way that you can do that is just head over to adafruit.com and buy yourself some hardware from them. They have all sorts of the different microcontrollers themselves, as well as different things that you can plug in to your microcontroller in order to interact with. And today's thing for me is, I'll get the camera pulled up here, is one of the Qualia S3 driver with one of the relatively oddly shaped displays, let's say. 5 is this one. All right, and let's focus it in. All right, so I've got the Qualia driver board. My camera is not quite wide enough to keep everything all the way in focus, and we'll want to be, the screen is kind of the business end of this project, so we'll be mostly focused on the screen. But I do also have this big red push button plugged in, and that is just connected to the little JST A0 plug right there. It's got alligator clips, which then clip into the leads on the bottom of this. So nothing too complex going on for the hardware just yet. And then software-wise, as you could see from the title or the foreshadowing from the GIF a little bit earlier, the project that I'm working on is a kind of like a Pacman clone. So it's a Pacman where instead of you having a big map where you can run all around everywhere, you just have this one sort of hallway you can run back and forth. Basically, you press a button in order to turn Pacman around, and that's it. So you can chomp the little pellets, and the part where we're going to start working right now is adding the ghost, because what you can see right now is Pacman's running around, he's chomping pellets. I do have the big pellets, which are candies or whatever. I don't know what they're supposed to be, but they make it so you can eat the ghosts, but I don't have any actual ghosts yet. So that is where we are starting right now, is adding some ghosts. Tiny bit fuzzy. It is. If we turn the light, it'll be better. And yeah, it's quite a bit fuzzy, but it's mostly because it can't focus without enough light. But then it becomes a game of the glare. I can sometimes win and I can sometimes not win, but we'll see how we do. Nope, that's the wrong way. All right, and then we have a little bit of a legitimately awkward thing in that it can't really focus on the entire width of the screen because the way my camera is, it's at an angle. So we kind of get like a weird little shift where you're really eyeballing it super close. What you'll see is half of my screen is in worse focus than the other half, but that is just how we got to do it because that's how my camera is. Okay. So where is CodePy? Wait, we're not going down far enough. Here we go. Okay, it's not even open. All right, so this project right now is built in a couple of parts. There's the CodePy, which is the main script, but it really doesn't do that much in CodePy. It instantiates a game object, chomper game right here, which is a group. So it extends group so we can put it on the display. And then it also just manages everything inside the game, which includes the player, what I kind of call loosely the map. So the tile grid that represents everything in the world. This all gets managed inside the game, and then what we're going to do is add the ghost right now. And in order to do that, we're going to make sure, do I have a ghost entity? I think I do. Ghost. Okay, so let's take a quick look at this. So ghost extends entity. Entity is basically like a tile grid that also has a direction. Oh, and it can cycle through multiple sprites. So it's like an animated tile grid that has a direction. That's pretty much all an entity is. It's a helper class that represents that. Allows you to set the direction to up, down, left, right. It doesn't handle movement by itself, so some other part of the code still needs to actually move it in the direction it's facing. But this code allows it to have a direction. And then it also has collision, which is nice. So we'll be doing a collision check on the ghosts and the player in a little bit. The first thing, though, is that a lot of these classes actually came from an older project which had a larger map. And it was, not only did it have a larger map, the map was being parsed out from a tiled map. From the tiled map editor, which sounds very non-specific, but is actually specific because it's the name of the map editor, tiled map editor program. This program is like an open source map editor, and our map was in the version of Pacman that I made before was built inside of that editor. And so the thing is that these classes probably still have some references to some stuff that's in the tiled map, which we're not using. We're going to cut anything out that's there. So we have a direction. We hold a tile grid, which gets a palette. We have a width and a height and a tile width and a tile height and a default tile. So we just set all that stuff up. Sprite. So this gets called in order to cycle through the different sprites in the animation. That looks all good. Setter for the direction, getter. So these are just, we won't need all of these. Might not even really need any of these, but I'm going to leave them for now. Yeah, this goes along with them. I don't know if we'll end up needing it. X and Y. Setters, tile grid, is colliding. Actually not other entity. Okay, there's actually not anything referencing the map, which I'm kind of surprised. On the player, which there is also a player helper object, there was some more stuff referencing the map. Although this is entity, we need to be looking at ghost a little bit as well, actually. Second here. Okay, so it is, every time game tick is called, it says if the direction's not none, get the pixel location of the next place where we would step to, basically. Next tile chords. So that's getting the X and Y coordinates in the map plane system, in the map coordinates. Is tile movable? We don't really have that concept anymore. At this point, every tile is movable, so I think we just get rid of that. And we actually also don't really have the concept of up and down directions, so I'm just going to get rid of both of those as well. And then we don't need any of the else. We will eventually need logic that teleports us to the other side when you run off the edge. I might move this out of Ghost and into game. But at that point, Ghost really doesn't have much need to exist, I suppose. So inside game tick, so this gets called really, really fast from CodePy. It calls game tick on player, which will ultimately be responsible for the animations, which in Pacman, the player animation is the chomping of the mouth. And then it handles the movement right here, including the logic to teleport to the other edge for the player. And then it also handles the logic right here for eating pellets. And then it would call game tick for every entity. I mean, it does call game tick for every entity, but right now we don't actually have any entities. It's an empty list. But I think we'll make it so that we have a ghost, and then we need to create our ghost. Let's say so a lot of these could stay the default, but bitmap and pixel shader do need to be filled in, but they will be the ones we already have, although they are a little bit lower. So I'm actually going to come down here. I'm actually going to come even further. We're going to do this after, like, wait. Are we doing this twice? Yeah, I don't think that's just happening twice. I don't think we need to do that. Let's make sure that doesn't break anything. JP had the same screen at driver board. I think it was JP Project of the Week. There is, so the one that I've got is, I didn't catch Project of the Week, or Product of the Week, I should say. I didn't catch it this week, so I'm not sure. This one that I've got is the 240 by 960, and there are a couple of other ones that are like, not the exact same, but are similarly kind of oblong. I think there's like an 840 by 360, or I don't remember them all now. How's it going, Orbital Cat over on YouTube? Thanks for tuning in, my friend. Hope you're having a nice day. Let's stop that one. Okay, so we did not break anything. I am going to put the ghost down here, I think just after the player, right? We might as well. So let's say ghost. Actually, I think I have it pasted, right? Or copied. Ghost is ghost. That's going to be the sprite sheet, and then that's going to be the pixel shader, which is self.palette. And then we can say self.entities.append the ghost. And then we can also append the ghost's tile grid to self, which is the group that represents the game. That way the ghost will actually get drawn. So we should get a ghost, but it will probably be just somewhere not moving. Well, it might move, actually. I don't know. Maybe it will move. I don't know. Probably it will crash. Most likely it will crash. It didn't. Okay, we got a ghost, but the problem with our ghost is two problems. One of them is it's outside the map. It's outside the walls, and then the other problem is it looks like Pacman, not a ghost. So let's fix that. think for that, we can just use the default tile here. So there was a default tile, and that is the number, the index of the tile, which is, we want ghost 1, 2, 3. So it's actually 0. So this is 4, 9, 10, 11, 12 is the ghost. We could say default tile 12, and then that's already set up to draw it for us, I believe. It will be still outside. Yep, there we go. Okay, so we've got a ghost. It is still outside, so let's work on that. That's probably just as easy as this, basically. Same thing we did on the player there. You want to set that Y value. It's not a self, though. We're just going to say ghost. I think there was an X and a Y in the constructor, wasn't there? But that's fine. 12. This feels pretty random. This feels pretty magic numbery. I don't exactly remember why I came up with 12 there. 15 makes sense because the sprites are 15 by 15. 12. I don't really know why it would be 12 plus 15. Maybe 12 is how far off the top edge we are? I don't know, because there's also scale involved. It was a Qualia S3 RGB666. Yep, all of that is definitely the same display board that JP was talking about a month ago. I gotcha. Okay, so it wasn't this week's one. But yeah, that's exactly what this is, Qualia RGB666. I have the driver as well. RGB666 40-pin TFT driver. Okay, so we've got a ghost. He's actually inside of our hallway. He's not moving, and he's also not like hurting Pacman. It should be that when you run into the ghost, then you lose a life. And in our game, I think we're just doing it to where you lose the game. So let's do that first, even before we worry about movement. And where should we do that? I think let's just do that inside of, so I mean, technically, I guess we should be calling game tick on, and then yeah, just direction was never set. So actually, if we would just set direction, then the ghost would probably move. But our next problem would be is there's no logic that is teleporting it from one edge to the other, which means it will just keep running off the edge forever and ever. It's not very useful. So let's do the collision first. So let's just say if, so inside game tick, we're going to say if self dot, is colliding? Yep, is colliding. And then we're going to say the game object, which got passed to us right here in game tick, the game object. And there is a player entity right there. So we can say basically for this ghost, we're going to be looping over all the ghosts, calling game tick. So when we are on this one, we're going to say, is this ghost colliding with the player? If it is, then player loses. We're just going to say like, game object dot game over equals true, which I don't think even exists yet, but I'm about to go add it. There is a game over, actually. Oh, no, that's the one I just added. Okay. Thoughts on Temple OS? I do not know anything about Temple OS. So I basically don't have any thoughts on it. Is it like a type of Linux or is it a mobile thing? Yeah, I don't know anything about it. Game over, we're going to set that to false right here. And then inside a game tick, we're going to make a top level check for is the game over or not. So we're going to say if not game self dot game over. Then we do the tick, which will make everything happen. So basically, when game over is true, it will make it so that game tick is pretty much not doing anything, right? Nobody will be moving, no pellets are getting eaten, no ghosts are hurting us anymore. I mean, we already lost to a ghost, but do that. Okay, so now when we run into it, we should get a game over. And then that should stop everything from moving. So let's check if that works. And our ghost doesn't move yet, but it should just stay on the edge there. And we should be able to run into it to test. Oh, actually, we don't even have to wait because we also spawn at the same spot, and we already know that that's working because nobody's moving. Perfect. Let's also do like a print game over just so we have like some more one-time sort of like output for debugging and stuff. Print game over. We'll probably also do something where it like shows the score maybe, and it sets it to where if they press the button then it will start the next game again or something, but now we'll just do it like this. This is a display I got for rectangle RGB TTL TFT 4.5 320 by 960 no touchscreen. That one's close, but it's actually a little bit taller in the small orientation. Mine is 240 by 960. So yours has got an extra, what is that? 80 extra 80 pixels on the small, on the small side. You've got a little bit of extra room still. Open source OS with 3D sprite creation baked into the console. Interesting. 3D sprite creation. So this is like basically aimed at like game developers, is I'm assuming the gist of that. Temple OS. 64-bit non-preemptive. Oh wow. I like the kind of like ASCII GUI. Oh, this might not be the same thing. This is not the same thing. Yeah. This is like a temple like churches. That's a different thing. Maybe let's say Temple OS 3D sprites. The space makes all the difference there, it looks like. 3D model viewer. Huh, interesting. I'll have to check it out. But yeah, no experience with it yet. All right, so we did get our game over there. That's good. Let's get our ghost moving. But let's also try to build the boundaries while we're here. So we have the game object. How are we doing the bounds in game tick for the player? So we're saying, where's game tick? Game tick, here we go. So let me do this also, get rid of the yellow lines. The bounds, okay. So we're just saying player entity 0. So we have self.display size. Display size. So on the game object there is display size. Okay, so yeah, let's go back to our ghost. Okay. So if we're moving right, if self, actually I'm gonna copy it. You know what? We're gonna copy paste action this. I'm gonna go big, then split. I'm gonna go back to where we just were. Game tick down here. Because player is an entity and ghost is also an entity. Therefore, the logic is basically the same, honestly. We can say we just do self.x and width, and we just get rid of all of these. Oh, not that one. That will be game object display size right there. Get rid of that. Game object. There's another one of those we get rid of. Okay. And right. Okay, yeah. Movement is still somewhere else. Movement must be in here. I see. So I'll probably move it to where the logic that teleports the player to the other side is here inside a player game tick. Whereas right now it's actually in the game object game tick, but I'll probably move it to keep it consistent. I think I like that in the helper object better. So it basically moves the player and then it does the check. So we'll keep that the same. Well, we're inside. Yeah, we'll keep that the same. So let's go and do those first and then these. We already have colliding. Okay, so now as long as we just put a direction on our ghost, it should start moving. So we should not spawn it in the same tile as the player, though, because that means we'll instantly get hit by it. Let's move it some. To the right. So I think this is like pre-scaled. So we're going to say like move it 15 pixels, but that's actually going to move it 15 pixels times 3 because I have a scale on the group. And what I want is for it to be like 3/4 of the way across. So let's say display size 0, integer division over 4, and then multiply that by 3. And that should get us pretty much, you know, right to 3/4. It might not be exact, depending on your screen size and the integer division. Be pretty close. All right, let's close that one. Let's put that back. Let's get to here, restart, run it. Ghost is gone. Okay, so I think though, because I did the 15s wrong, we need it to be way less than this actually. We need it to be like, well, we need it to be like basically over 3 on top of this, which is ironic because we're multiplying by 3, and I guess we could just not do that. Yeah. This is a little bit awkward to multiply by 3 and then divide by 3, but I actually kind of like it better than just getting rid of the multiply by 3, because if we just get rid of this, when I'm reading this code, in my mind, this is telling me that we're going to spawn at 1/4 of the way across the display, like right about here-ish. But because we actually have a scale of 3 going on, we're trying to get to over here, and even though this is a weird way to write it, it's what we need, or it's one of the ways to write it that makes it more clear in my head, at least, what it's doing. So that's the way we're going to do it. So our ghost is over there now. Let's give it a direction. We should be able to just say ghost.direction, and let's start it going left. That way it's moving towards the Pacman at the beginning. Goes a little crazy when you save, I've noticed. Yeah, we need to click pretty fast because we're going to be going towards the ghost. All right, nice. Okay. And now one thing is we move at the same speed as the ghost right now, which makes for the game to be not very hard and not very fun. So we actually want to move a little bit. We want the ghost to move a little bit faster than Pacman. That way it can actually chase you down, and that way you actually have to use the button to turn back and forth to get away from it, and importantly to get to the big pellets that let you eat the ghost. Let's make it so when the game is over, if you press a button, it will start a new game. So what we're going to do is we're already checking the button right here. We're going to say, is it printing pressed even though the game is over? Yeah, okay. So let's just add a thing in here that says if game object game over. We're going to say not first. So if it's not game over, this is the normal stuff to do. And then else if it is game over and you press a button, then we want to restart. Basically, we want to begin again. So we're going to effectively say score 0. Maybe we should have like a game object dot restart. Actually, I think we should have that. Or maybe it should just be game object dot start, and we should call it the first time too. I don't know. Let's do just a restart for now. Basically, we want to move the player back to the left. We want to move the ghost back to the right. And we want to reset the direction to be the default ones. And we want to respawn all the pellets. I don't know if I was just on 0 or I don't exactly remember where we started the player entity. So ghost is actually on entities, which is a list. Technically it's entity 0. If we ever add multiple ghosts, we're going to have to deal with that. For right now, I'm just going to hard code it to the 1. Okay, player to the left, ghost to the right, and then respawn pellets. I think we can just say spawn pellets. Although, yeah, okay, so if there were any pellets that weren't eaten yet, they would just get turned into pellets again. Just fine. That should be no problem. Previously, the only time we were calling spawn pellets, there were no pellets spawned, so I wasn't sure if that was going to cause trouble, like it would double them up or something, but that's not the case. It's just going to overwrite the ones that still exist if there are any. So now when we're in game over mode, if we press a button, we call restart. Restart should get us to where we can play again, I think. So I'm going to run into it on purpose. Okay, game over. I'm going to press a button. Okay, one thing it needs to do still is it needs to set game over to false. Otherwise, it stays paused. So pretty close. Set game over to false. Okay, game over. Press. All right, back in it. Nice. Ooh, got a double press there. Didn't even mean to. All right, looking good. Let's make it so the ghost goes a little bit faster. Let me also pull up the actual game here real quick. this is the inspiration. This is where this inspiration came from. And in this one, what you can see is the ghost is faster. Ooh. Got me from right side that time. So if I get myself going in the same direction as the ghost, it will gain on me, and eventually it will catch up to me. Feel like that it's gaining. So you pretty much have to use the pellets in order to live. So does Ghost have a... doesn't have like a movement delay. Actually, player doesn't have a movement delay either. Oh, it does. No, that's animation. How fast are we calling game tick right now? Oh, okay, here's... I see what I did. Okay, so we put the delay... We have a tick delay. Actually really low, though. All right, we're going to swap this around a little bit. Right now we have this tick delay here, which is like our outermost logic in CodePy. We want this to be deeper, though. I want it to be the player is going to keep track of its own movement delay, and the ghost is going to keep track of its own movement delay, and they'll each have different movement delays. That way the ghost can move slightly faster than the player. And then on the CodePy in the loop here, we're just going to call game tick as fast as we can. The player will slow its own movement down with its internal check. The ghost will do the same. Yeah, and then it should be fine that that's getting called faster. And then it will actually make it so that our button can even be a little bit more responsive, because right now we actually have this kind of effectively like an extra delay in our button. So we're going to say move delay. Step delay? Let's call it move delay. And I'm just kind of guessing. I mean, right now it's hard to say. It said that 005, but that seems really fast. I think once we split this up, we don't need it to be quite so small. Say start like that and then see where we end up. We need a oops. Okay, so if the current time is greater than the last time we moved plus the delay, then it's time to move again. We do all of this. I think I'm ready to delete this stuff. This was logic about is tile movable, which we don't have the concept of anymore. And by anymore, what I mean is like this version of the game doesn't have that concept, but some of these classes I took from an older version of the game that I worked on. Okay, so the player should slow itself down now. Let's get rid of this logic. And let's just call game tick as fast as we can. It's going to call player tick, which now has this delay in it. And then we're also going to do a similar one inside of ghost. So 0.5 I did on the player. I'll start with 0.4. Another thing we might do eventually is maybe the ghosts, as you get further in the game, maybe this will go down more, so the ghosts speed up over time. Like once you get to higher levels, basically. You don't really have levels per se, but the same thing here. If the direction is not none, if we need our, we actually need init def init. Actually need to make sure we put the right stuff here, otherwise it won't work. Cool stuff. Practical, even though it's game. Yeah, I think it's nice. Like games, honestly, games kind of push software in weird weird ways. If you want to make games, you oftentimes can end up finding some like neat kind of code modules that you end up making for a game, but ultimately will apply elsewhere. All right, so we want to call super, which we can basically gank from here. And then we only have one, so I don't need to bother with the now variable. I'm just going to say last move time. Arguably we could even put this on the entity class if we wanted to, but now I'll leave it here. Last move time, time.monotonic. And then inside of here we go if, so here I will get a now equals, oh, you know what we needed to do inside player, which I didn't, which is we need to update the last move time. We checked it, but we never updated it. So I'm going to hopefully not forget to do that, but I'm going to keep going here first. Now equals time.monotonic if now is greater than self.last move time plus ghost dot move delay. What? Are you serious? Come on now. There we go. Okay, then we do all of this stuff. And we could put the collision check in there as well. Currently, it's actually outside of that, which I guess is why we were colliding even before we started moving. I think we were, at least. Okay, here we go. Now we say only when the move delay is passed, that's when we do take our step. And we only need to check for teleporting from the edges, like when we take a step, because obviously if we didn't move, then we didn't hit an edge. We only need to check collision. Actually, we should check collision whether or not the ghost moved. Yeah, because it could be like a frame where the ghost doesn't move, but the player does. And in that case, it should still count as losing. In fact, I think we just move this out of the entity, right? This should just be in the game tick, I think. So tick the player, teleport if it needs to, eat the pellet if it needs to, tick the enemies, which are entities, and then after that's done, do the collision check. So and we're inside the game, so it's no longer self, instead we're going to say, we could do it either way, but I'm just going to say self.player entity is colliding, and then technically we only have the one ghost, so we can just hard code it to 0, but if we add multiple, then we could loop. So if the player's colliding with the ghost, then we get the game over, we set the self game over, Now, because game tick is getting called faster now, it means even if one or the other did not take a step that frame, you can still get to game over. It's perfect. I think that's exactly how we want it. Especially if they're going to move at different rates. Which my guess is we're going to have to tweak the speed, probably. Somehow, we went back to the ghost, being Pacman. Why though? That's okay. Well, there's okay, but this is the wrong file. Oh, okay, that's where our 12 came from. We got 12 plus 15. That's because we're setting the map to 12. And then 15 is each tile, so that gets us to the middle. So our map is technically 3 tiles tall, but the top tile and the bottom tile are both walls. I love when my own code does something and I'm like, what? Why did that happen? Agreed. I think that's honestly one of the funnest parts of programming for me is like just seeing what goes wrong. Like there's never a dull day of what goes wrong in programming. Yeah, no, I don't know. That makes no sense to me. I guess it's because we are. So we're calling entity game tick. We're calling entity game tick. Are we calling super? We're not calling. We probably should call super in here. Is entity. No, okay, never mind. Entity doesn't have a game tick. Why would it be changing? Okay, we need args here. Which we do. The stars are on the other side here, I think, right? Oh, wait, no, it doesn't have them here. I think we need those. Because we want to pass these through, in particular, default tile. Which for the player happens to be correct, but for the ghost is not. That's not how you do that. You still do it at the front though? And convert string to int. So it's tough because line 27 is actually a bunch of lines. I think any of those should be ints though, or strings rather. And I don't get why it changed. Like we had the ghost correct a second ago. Does this like not preserve type or something? Does it need the double star here as well? I was thinking that was only 1 star, but maybe I'm wrong. Oh, okay. I don't do a lot of poly. I don't think my button press is working. Oh, it is. Wow, you just have to hit it really fast. I'm not sure the ghost, it's not gaining on me though. Oh, I never actually updated my last move time still. I said I needed to remember to do that and I didn't. So it's actually both things are moving at the speed of the game ticks right now. Whoops. All right, so here we need to say this. Last move time equals now. We need to do the same thing for player. How's it going, Axel Magnus? Hope you're having a nice day, my friend. Let's put that one back there. Oh, okay. Ghost is now faster than the player, but both are very slow. I am surprised, actually, how slow that is, because we did 0.05, which is 20 times a second, which is pretty fast. It's a big display. Is auto refresh on? Wondering if we're refreshing the display sometimes when it's not changing. Okay. So what if we would, let's see, we're not passing the display. We're gonna say moved equals player moved. I don't know if this is actually gonna make a difference. If it doesn't, I'll probably cut it back out. We're gonna return true. Oops, I accidentally deleted the end. If we actually moved, we're gonna return true, and then if we didn't, we're gonna return false. Same thing on the ghost. And in here, we're gonna check if either one of them moved. Technically, I'm gonna take this loop off for right now. past the display here. So basically, we only refresh the display if something moved. And to see if that makes it so it seems like our stuff moves faster. And if it does, then basically that will tell us that we were spending time refreshing the display sometimes when stuff wasn't moving. But no, honestly, that looks like the exact same speed to me. So, yeah, I don't think it made a difference. I guess, though, the other thing is we're only moving by 1 pixel at a time, which is not very much. And it is a 960 pixels wide screen, so it's going to make it seem like we're moving pretty slow. All right, I have got to run to the restroom, so I will be right back as I take another drink of coffee, which is not helping, but BRB. Okay. All right, so I want them to go faster. There's a few ways we could achieve that. We could make them take more than 1 pixel step at a time. That will start to make them look like they're kind of chunky, though, if we go too far with it. The other way we can make them faster is just lower the move delay. So let's try on the player, kicking it back down to where it was. And on the ghost, let's keep it with being slightly less and see what that feels like. Okay, it's actually still feels slower than before. Also, not sure that it's catching up. We're creating a dictionary for no reason. In fact, we're doing a bunch of math in here for no reason also. Let's get rid of the return true, return false. Let's just go back to auto refresh, I think. That didn't really seem to make a difference. It just adds extra logic. The print statements, they probably are some. Yeah, no, they probably are. They slow it down a little bit, yeah. I should turn them off, some of them, or most of them, really. I wouldn't expect it to be to the degree that we're seeing, but it could be possible. I do have a lot of prints in there, actually. It should be auto refresh true by default, I think. Make sure it's even working or not. Okay, we're actually a lot faster now. And the ghost is probably too fast, but I put it down to 0.0002. We're printing less. We could still print even less. It looks like we're still creating a dictionary, maybe. We could get rid of that, potentially. Although map tile change, that's only whenever we eat a pellet. So, like, realistically, it's not getting called that much because there's only 21 pellets. 0.002 is what I'm looking for on our ghost. So let's get back into here. Let's make our ghost not so fast. So if I put the ghost back to 4, will we get to the point where it's actually going to gain? Because a second ago it was like it wasn't really gaining. The ghost gaining on me? I don't think it is. All right, let's get rid of the other print. I wonder if this would be faster if it weren't a dictionary. It's nice because it's a dictionary, it makes it labeled, but it's technically just 2 ints. It could just be 2 ints, or it could be a tuple of 2 values. All right, we have way less prints now. I'd say the speed of Pacman feels pretty good. The ghost, I don't think is gaining on me. So I'm not actually convinced that our time difference that we're using right now is big enough to matter. One thing we could do... Okay, hold on. What if I just comment this out, do we run faster? So basically, is this part of the code using up enough CPU that it's slowing us down? No, not really. That seems like the same to me. Okay. So there's no gain to be had by trying to make this smarter, really. If we go to 6 here, does it make it enough to where the ghost actually gains? Oh, yeah, the ghost feels way faster now. I will say, though, it feels more like the online game. Because I do think in the online game, the ghost feels very punishing. Feels like way faster than you, basically. You have to really be good about getting your pellets to be able to eat it. Whereas it's actually... If you start pretty far away from it, it takes like 3 or 4 trips all the way across the screen here. Which is not too bad. I feel like that's a good starting point. And then eventually we could get things speeding up. Like maybe eventually we get the ghost to moving a little bit faster. Maybe we also make the Pacman move a little bit faster so that you kind of have to make your decision quicker. And then once you get to like super late game levels, potentially we could have them both start taking 2 pixel steps instead of 1 pixel step. Which will basically make it seem like double the speed. Instantly, so we have a lot of room, I think, to speed up still. So let's try to get our eating of the big pellet to turn the ghost to be edible. And we kind of need the visual indicator for the ghost being edible in order to be able to, like, see if it's working very well. So I think I'm going to do that real quick. The ghosts turn blue whenever they're edible, and they actually blink between blue and white whenever they're about to turn back to regular. So I actually want 2 new tiles. Technically, we could get rid of these 2 Pacmans and these 2 Pacmans. I'm not going to mess with it for right now, though. We have empty spaces still, so we might as well just fill them up. All right, there we go. What color should we make the eyes when the ghost is blue? It's kind of random to not have these next to each other, right? Maybe we should move them next to each other. I mean, it would be kind of random to have a gap here, but whatever. It's fine, I think. Red eyes on the blue ghost. Coming up. I like it. Thank you for the idea. Let's go. Well, we can't do paint bucket because... yeah, I can actually. Okay, well, I can't because I'm not on this one. There we go. Okay, but then it does make it so I can't paint bucket the eyes, but that's fine. Let's do... Could I have done it first? No, because it's already red. Okay. Then we'll just pencil the eyes like that. And then this one we need a white one, but we have... Should we change the eyes to black? The whites of its eyes? I think we probably should, right? Did I just put a... Okay. Okay, so when the ghost is edible, it turns blue, and then a little bit right before it's about to become not edible anymore, then it blinks between blue and white, and then whenever it's done being edible, it turns back to red. So let's save this, which is, I'm actually going to save the GIMP file, which I don't think I did before. But I should have, because I want to keep the source file for this just in case. But then obviously that's not what we're going to put to the device. For that, we're going to export A, B, and P, which we can then copy to the device. Okay, let's do some things. All right, so Ghost. Let's look in Entity, because Entity has sprites, which can be a list of sprites, the indexes within the sprite sheet, that entity can cycle through whenever you call next sprite. So for the Ghost, we don't actually need to be calling next sprite anytime except for when we want it to blink. When we want it to stay red, we don't need to, it's not animating, so we don't need to cycle. When we want it to stay blue, it's also not animating, so we don't need it to cycle. But then when we want it to blink black and white, that's when we're going to use our next sprite mechanism, I believe. So let's do that after. Let's just work on turning it blue first. So what I'm going to do is on Ghost, I'm actually going to make a self.edible, which will be false by default, and then we'll set it to true whenever the player eats one of the special pellets. And then when it's true, it will have different logic for the collision, which we'll worry about in a minute. But it will also change to its blue costume. But we actually want to do that where? We want to do that when the player collides with the big pellet. So that's already actually happening down here. So right now we're actually checking both types. We don't want to do that. So 4 is the small pellet and 9 is the big pellet. I'm actually going to change this to 4. And then elif current tile type is 9. We'll have separate logic now. So some of it's the same. Change map tile, that's going to be the same. Score, that could be the same. Pellets -1, that can be the same. Yeah, maybe we should have done, maybe I should do it this way, actually. That way we're not copying as much code. So current tile type, if it's 9, we want to go and set the Ghost to be edible, which we are in the game object. We don't need this anymore. Let me delete that. We are in the game object, so we're going to say self.entity is 0, because we know that's our only Ghost. We're going to say .edible equals true. And then we're going to go self.entities 0, and we are going to say tile grid 0, 0 equals. So that's 4, 9, 14, 15, 16, 17, 18 is blue. current tile type, if the current tile type is 9, so if we ate a big pellet, turn the ghost to be edible true and set its tile to 18. So right now it has no logic to turn back, but let's see if even that part is working or not. I'm always a big proponent of kind of take the smallest steps you can. Although sometimes I don't follow my own advice and I do a bunch of stuff. One positional. Okay, here's where this helps us out, because if I had changed even more, then we'd have to trace back through all of this. So 98 is what? Right, we got rid of display. Good call, thank you. Nice. All right, let's work on the collision. So when the ghost is edible, then if we run into it, it's not game over. Instead, it's like you get some points or something, I assume. That is where. So that is in game tick. We had entity is colliding. So that's now going to say if self.entities 0.edible. So if it's not edible, then we get the game over. Else ghost is edible. Nom nom nom. Then we do what? I think we should. So we want to spawn a new ghost. Do we do it instantly or do we wait? It waits. He turns around. So what it does is actually the eyes. It's like the eyes fly off the screen, and then once the eyes get to the edge, that's when it respawns. So it actually does give you a little bit of time before it respawns. I think what I'm gonna do is I'm gonna say self.entities 0.respawn time equals, and then I'm gonna say now plus ghost.respawn delay. We don't have a now yet. Now equals time not monotonic. Then we'll make a ghost.respawn delay. Let's call it 0.4 seconds, excuse me. Okay, so basically that will be none most of the time. We'll say if not respawn time self. So respawn time is going to serve as a, like, when it's none, our ghost is currently spawned. And when it's a number, we are waiting until that number to respawn it. We're not making a new one, but we'll choose a location for it and set it. and make it start moving again and stuff. What's wrong with now? Oh, okay, it's if respawn time is none, we do everything just like we were before. Else, if it's not though, it's then it's a time. So then what we do? Do we have a now in here? We do. Let's take this out. So we know that we are waiting to respawn, so we're going to say if now is greater than self.respawn time. Then we want to respawn, which means we are inside the ghost. We do have the game object though, so we know where the player's at. I want to spawn like far enough away from the player that they don't just lose. Although, does it do that? I don't know. It comes from the side. Just spawns from the side. So yeah, let's just pick a side at random, I guess. Is that, yeah, those are inclusive, I think. So self.x is 0, and also, what am I doing? Okay, let's do that actually. That's a little bit more like actual code. So if we're gonna spawn left, we set it to 0, we set the direction to right. And then else, if we spawned on the right, self.x equals, it's gonna be, it's kind of magic numbery, but it's gonna be 21 times 15. We could look that up off of the game object or something. Be slightly less magic numbery, but I'm gonna leave it like that for now. That's gonna put it over there. We do want to set it to be the direction left, direction, entity, direction. And then if we respawn, we also need to go ahead and set respawn time back to none. Otherwise, it'll try to respawn again, which will not be good. All right, so when respawn time is a number, we effectively don't take any steps. The ghost doesn't move, and we just wait until the number has passed the current time, or vice versa. We reset that so that it will flip us back to the rest of our logic. We basically flip a coin to decide if we're going to spawn on the left side or the right side. If we spawn on the left side, we set X to 0. We set direction to right. We spawn on the left side, we set X to the far right, and we set direction to the left. It sounds good to me. So as long as we're setting respawn time when we eat the ghost to the current time plus the delay, I think that should work. Yeah, I think that should work. The ghost, its eyes are not gonna fly off the edge. In fact, I think it's probably just gonna stay wherever it's at. But like logically, I think it should work. Maybe. Eat it. Yeah. It stayed. Oops. Okay, yeah, and then it's never turning back to red, so I can just eat it over and over again. All right, let's make it disappear when you eat it. And maybe later, eventually we might do the eyeballs flying off the edge. But for right now, let's just make it disappear. And so for that, what we're gonna do is we chomp it, and then what we're just gonna say self entities 0 tile grid 0 0. We'll reset it to be not in edible mode as well once we do this. So we'll set this to, yeah, we could do any of the empty tiles technically, or we could do the black tile. I think let's just use this one. So that's 4, 9, 14. Let's do 14. So that should be transparent. And then when it's time to respawn, we will set it back to the red one and we'll turn edible off. When it's time to respawn here, we can go self.tilegrid 0 0 equals the red one, which is 4, 9, 10, 11, 12. And edible, false. Whoops. One thing we still don't have is the ghost turning back to red on a timer. Right now it just stays blue until you eat it. It does correctly give us the game over though, which is good. That means when we're turning back to the red ghost, it's working properly. Okay, when it respawns, it's red. So I think we're ready for blinking, right? I think we're ready for blinking. How do we want to handle blinking? I think we want to have an edible duration. Which I'm gonna put on 2 seconds to start. So first let's get it turning us back to unedible after that delay is over. So we actually need a self turned edible. I want to say editable. Turned edible at set to none. Let's make this a property. That way we can have a little bit of logic instead of just having to set 2 variables. So if we are becoming edible, we're going to update the turned edible at. if now greater than self dot turned, actually we can say if self dot turned edible at, and because that will be none if it hasn't been set. But then we say turned edible at, so now greater than turned edible at plus edible duration. Back to non-edible. Not to false. The time doesn't need to be updated, but that's handled in the property anyway. So yeah, that should make it to where we turn back. We need to go self dot turned edible. I guess actually let's do that in the property even. That's even better. Nice. Okay, let's go here. So else if new val was false, then we'll say self turned edible at, and we'll just do none. That way it goes back to skipping that part of the logic since we did the and on there. So we should have 2 seconds of time now where it's edible. I think I still ate it. Oops, I didn't mean to do that. Not to eat, nope. Okay, so yeah, oh, that's weird. Oh, wait, we didn't turn the color back. We need to turn the color back. We can do that in the property too, actually. Let's do that in here. So if new val, if we're becoming editable, then we're gonna say self.tilegrid 00 equals blue, which was 12, 13, 14, 15, 16, 17, 18. And then if we're becoming non-editable, we're edible, we're going back to 12. And then we don't need to do this here anymore. Instead, we just set edible true. That's a property, and it handles everything else for us, which is super nice. I actually like that a lot better. All right. I think I underutilize properties sometimes. They're really, really handy to make it to where when you change a state value, oops, you can also have some other stuff happening. Oh, I think the big pellet spawned like basically where I took my first step. So I think coincidentally, it looked like the ghost started out as blue, but I think what actually happened is the very first pellet I ate was the big one. Yeah, because this time it started red. It's going to get me. Oh, it's so close. All right, here we go. Do we have 2 seconds? Yeah, it turned back to red. Nice. Okay. So now we just need the blinking. Before we go back to red, we want to blink. How long do we want to blink? Let's call that the edible warning duration. We can always play with these times a little bit. I think I'm gonna make it 3/4 of a second to start with and see how that feels. So let's go and also set edible warm time equals none. So then in here, we're going to go edible warm time equals the current time, which I'm going to put in a variable and then reference rather than calling time.monotonic multiple times. So if you call it multiple times in a row, then you could get different numbers. So we say now is when we turn to edible warm time. That's going to be now plus the value we just set, which is edible warning duration. No, it's going to be now. It's going to be now plus the difference of this minus this. So our full duration is 2 seconds minus 3/4 of a second means 1 1/4 of a second after we turned edible. That's when we're going to start blinking. 1 1/4 second later, which is total duration minus the warning duration. So, okay, so now we can say I don't think we care about the direction. So if now is less than self.edible warm time, then we want to start blinking, which we're going to do by setting current sprites to be a list of the sprites we want to blink between. Self.current sprites equals the blue one and the white one, which is 18 and 19. Let's call it 19 and 18. That way our first blink is too white since we were on blue to begin with, like before we got into this state. So we set the current sprites, and then we just call, well, we need the animation delay. What's the player animation delay? 0.2? We go on the same speed as that, maybe? So that means 0.75. That means we're only going to get like 3 blinks. All right, let's call this 8, and then let's actually make this 0.1 and see if that's too flashy. Okay, so we're gonna actually say if self.edible warm time, and because we're gonna set that back to none when we don't want to be blinking. Maybe we should be making more variables. I'm kind of making some of these variables do double duty, like it's a time and it's also a Boolean for if it's supposed to be happening, but so then we're gonna say we need a last animation time. Is that happen inside of entity though? No, that only just changes the sprite index. Okay. Animation time none. All right, so then, okay, so we know we need to flash. So we set our sprites. We say if now is greater than self.last animation time plus ghost.animation delay. Then we want to animate, which means for us effectively call next sprite, which is on entity, which we're extending. Next sprite will basically loop between these two for us. And then what we want to do is whenever we respawn, when it's time to respawn, we will set the edible warn time back to none, which means then we won't be blinking anymore. We're already changing the tile, the sprite. I mean, technically, I guess we could change these. We don't even really need to, honestly. It's a little bit weird because it's going to be called current sprites, but we only use it when we're blinking, which means anytime we're not blinking, we actually have this variable called current sprites, which contains two sprites that we're not actually using, which is not the best from a naming perspective. We may eventually change that. I'm curious, though, for now if it works. I'm always a does it work first kind of a developer. Orbital Cat, why does the OS need to create sprites? Yeah, that was a question for the from the YouTube we got earlier about the OS. All right, so we turn back. Oh, I'm not gonna make it. I don't think it blinked though. Just went straight back to red. Did I? Maybe I didn't restart though. Ooh, unsupported types adding and none. Game tick 399, 48. Oh, starts out on none, so we can't add it to that. So I guess let's start it out on 0. Or I suppose we could use timed out monotonic too, but it's effectively going to be the same thing. Oh, it seemed like it was blinking too fast. It's going to blinking instantly. Doesn't actually go to blue. So why is that happening? They're supposed to stay blue until it's time to do the warning. Should be 1.2 seconds after we turn blue. Ah, this is backwards. Edible warm time is in the future when we set it, which means that it's always greater than now when we first set it. We actually are waiting for now to be greater than it. We want to be waiting for that at least. Gonna get eaten. There we go. Now we get blinks at the end. Oh, it's not turning back properly to red anymore now. So it goes back to, doesn't go back to red, but it does go back to non-edible. Was there no big pellet that time? Yeah, so it's back to non-edible because we got a game over. Never knew you could make 2 hours out of this. It seemed to be almost done 2 hours ago. Oh, I mean, there's still quite a bit to do. It does sneak up on you as far as like once you get down into the weeds of a game, like you kind of spend decent chunks of time on things that seem small and innocuous while you're playing the game, but for what it's worth, I'll be back in the morning tomorrow. So if anybody wants to see more one-dimensional Pacman action, tomorrow morning at 10 a.m. Central Time over on my own channel, I'll be back at it working on this. I'm going to see if I can't figure out this bit right before. So we got a couple of minutes left here. I'll try to solve this before I cut it out for the night. I think, why? So it's got to be so, but we're setting this back to none, right? So we set that to none. Which then it should not trip this, because once it's none, then that will not be true. So we won't go to here. We won't call next sprite. Okay, I think what happened is we respawned. We set this to 12. But I'm thinking maybe we tripped this like one last time or something. Doesn't really make sense though, right? Oh, wait. This is when we're respawning though. That's not what we need. We want when we stop blinking. Which is where? It's where we set edible back to false, which is when we respawn right here. But that should be setting it to 12. I mean, when we do actually respawn, it's happening right here, so I guess we could just do it twice. I feel like it should take effect from inside there, though. Not sure this is actually going to solve it. Yeah, basically, it just keeps blinking. Okay, for one thing, too, though, it gets messed up if you eat a new pellet. It makes it hard to troubleshoot. Basically, a new pellet spawns, and then I can't really tell what it's doing. It looks like it just keeps blinking. Okay, it's because... No, I don't know. Why is it not turning back to red? Have a question. Is it getting is Gittick? Oh, is GetTick getting too long? Game tick, I think you mean probably. Yes, I know you prefer to get it working first, but it's a bit complicated, is it not? I mean, refactoring, maybe it's not that long. I don't feel like it's too long. I mean, right now, so like we have game tick for each entity. So this is the ghost game tick, and then we have the player game tick, and then we have the overall game tick, which is what calls it on the other ones. Some stuff I will still move, I think. Like right now, the teleporting from edge to edge for the player is happening inside the game tick, which I think I'll move to the player game tick. Possibly some other stuff too, but I think that's the main one. But after that, I don't think there's really too much in any of them. I think they all basically have almost, exactly what they need to do. There's some stuff like this where I'll probably delete some commented code in a couple of spots, but I don't feel like there is too much to be changed around. You could certainly rewrite it to be different, but maybe a state machine might have been a simpler representation of this, like a full-on state machine with like, here's the different modes, but we effectively ended up with a state machine, just not with a state variable of a single thing. But so do we ever print that we're changing back to non-edible? Okay. Yeah. It does. I'm gonna make it not spawn pellets so that we can try to not hit another special pellet. Just gonna make it not do this for now. Maybe that's why it's not changing back, actually. Maybe I was just always eating another pellet. Which means we probably need to tweak the times a little bit, because it stays editable for so long, that you almost are like guaranteed to be eating it, because it's edible for long enough and you move fast enough that you can get across the entire map to the next one. But it says back to non-edible. And it ate me. It gave me a game over. So edible must be false. But yet somehow we ended up on blue still. So I don't understand why, but I do think if we just added another thing in here that said if we are actually edible, because we know edible is false, and so if we don't call next sprite, which is what's doing our animation between white and blue, if we don't call that when edible is false, then we should be staying on red, because it seems like it's getting set to red, and then my guess is that it was just changing sprite after that. There we go. Okay, and we got 8 in there at the end. We got our blinks. We go back to red. Very good, very good. Okay. All right. Print the color state. Yep. I think we got it. That was going to be definitely my next step, though, is add more prints for when, I mean, basically just every frame, print what color it is, but we made it there in the end. All right. I think I'm going to pack it in for now. So I will bid you all a farewell for this evening. Thanks for hanging out. Thanks for the suggestions and the questions and everything in the chat. Always appreciate that kind of stuff. Like I mentioned a little bit ago, if you would like to see where this project goes, if you're interested in this and you want to see more, I'll be back tomorrow morning to work on it again. That's going to be 10 a.m. Central Time over on my own channel. I'll put links in the live broadcast chat, which is the Discord channel that we're in here when I get started. Yeah, thanks to everyone for tuning in, for hanging out. I hope you all have a good rest of your evening and a good weekend and all that stuff. I will see you tomorrow if you want to join in. Otherwise, later on. Thanks, folks.